Hi, this video is part of a series in which I learn about programming a retro video game on the Commodore 64 in assembly. The code I'm using is from the game Supernatural, written by Georg Rottensteiner. You may also know the game as Guns and Ghosts. This is not a tutorial, just me learning game programming. Enjoy the video. Hello coders. We're on to step 20, and I have to say that if you've been following this series, then you'll know some of the concepts that this programmer has adopted to achieve stuff. But if you're just starting with the series and starting at this point, if this is the first video that you see that you're gonna, then I suspect you're gonna struggle grasping some of the concept, because I'm no longer explaining all of the tiny details, because they're repeated over and over again. You know, we've laid a base that is usable and solid, and we use that now to lift us to a higher level, and that speeds up the programming process. In this episode, in this step, we're gonna change the items. So we already have items showing up. Now we're going to make them dissolve after a certain time. So we're gonna make them appear. That's already happening, but they're also going to disappear after a while. So after we kill an enemy, an item appears and it's going to disappear after a while. We're going to concentrate on the shells. So player shells, we have a maximum number of shells that we can hold. We start with 2, but that doesn't mean that we're actually holding 2 shells. So after we've shot our gun and it's empty, we can reload by standing still, right? For if we stand still for a while, then the reload animation happens and we start getting new bullets, and then we can shoot again, but only to the max, right? So let me show you what that looks like. We're gonna start Vice, which I have done now. Have I? No, I have to click it twice. There we go. I'm gonna make it a little bit larger. Well, we see our protagonist standing there. I can just move. I can just move around, and look at the bottom here. We have 2 bullets, and this color, this red and a yellow color, means that we have full shells. If I shoot one and I shoot another, you can see what happens. Shoot. If I run, nothing happens. See, while I'm running, nothing happens. But as soon as I stand still, the reload animation happens and I get new bullets. And I can shoot this guy and I have to wait again. Now I've got myself in a pickle. 1, 2, 3, 4. Oh, I can't shoot now. I have to wait for the... This is a mechanic that is in the game. You can see that I have health now. So I can pick that up. It gives me an extra life, as I have 3 lives again now. See what happens if I get this guy. Up, up. Oh shit. Oh shit. It's really turning into a game now. Oh crap. Ah, more health. We're gonna watch it disappear, by the way. It has an item time. There it went. See that? So that's quite a lot of stuff going on. I'm gonna try and get the zombie. Boom, boom. I have to wait again. It's a very determining. Okay, as you can see, there's now shells. I can pick them up, and at the bottom you can see that an extra shell has appeared, and now I have 3 bullets. I can shoot this guy. Hopefully, I'm good enough to do it. Right, we got health, we jump, and we're up to 3, and we're at the next level. So that's quite a lot of stuff going on, and you can see that it actually adds to the gameplay. but it's also pretty complex, and you can only do that when you have a good base. Now, we'll look at how that is done. To start off, I'm going to show you a tool that I've found. It's called Meld. If you're used to Mac, there's a file compare tool which helps you to compare different files. So I have two versions. This is the step 19 version, and on the left, and on the right is the step 20 version. And Meld, which is a free tool that I found online, shows you in a graphical way what the differences are between the files, and it allows me to track the changes that were made. So and I use this to step through the code. So I'm going to slide that out of the picture, and I'm going to look off to the right to see where the next change is, and I can talk about it and show you in the actual code that is here, that you've just seen me assemble and run. Okay, to start off with, you can see the text display. This is the text display that is put on every screen that is drawn, and you can see that there's been an addition of two characters, 224 and 224, and if you scroll a little further, the line below it is 225 and 225. That sounds like bullets to me, and if I go to the character designer, which isn't any larger than this, you can see our current character set, and characters 224, you can see here, it's 224 and 225, just the top ends of the bullets and the lower ends of the bullets, and their color determine their situation. These are bullets that I actually have. If I change it to 6, you can see this is the color of an empty bullet. So anyway, we have some new characters that we can use, and that we actually already use right here, 224 and 225. Now this change, it uses some new data, again underlining the importance of starting with a good design, because the data that we need isn't that extensive. If I go to this line here, we now have an item time. Remember that we want our items to fade out slowly. So each item, this table is indexed by item number, and the item count is the number of items that we can have. So that's the size of the table. And that holds a time. Again, a time in frame numbers, or actually game loop numbers. That's what we should call them. So we have that, and then there's the player standstill stuff, and there we go. There's three. Oh, there's the shells. There's of course the shells that we have. That is 1 byte, so we can have up to 255 shells. Basically, we're never going to fit that on the screen, but hey, there's going to be some kind of limitation. And the player shells max. So this is our clip size, basically. This is our chamber size. This is I don't understand guns. This is the number of bullets that we can max hold, and this is the number that we're actually holding. So this number is going to grow with every pickup that we get, every bullet pickup, and this one is going to grow with every time that we stand still and reload. Now, of course, we have to have a player stand still time. We have to measure the amount of time that we stand still. So we have to stand still for a while before we can actually start reloading, so that we use a byte for that. Now, we're going to scroll way back up, because we're going to start at the top now. Yeah, let's start at some of the constants that we use. So we've gone straight to the top. And then you can see, well, anyway, we've added some sprites apparently, so we're now, this number that we keep updating is purely for the copy sprites routine. At the start of the program, we copy the sprites to, under ROM somewhere, and there's a routine that wants to know how many sprites that we have divided by 4. So we have to keep updating this number, otherwise our sprites aren't going to show up. So then there's some, the code was sort of beautified. Everything was aligned here so that it looks a little bit better. No real changes there. Oh, something happened here. I don't know what. There we go. We get to the interesting stuff. Oh, also, if I go to the start of the code around this is still before the main game loop. We now have a function called start level. We were doing some stuff that was being done at the start of every level, so it basically has to do with painting the start line. Before, there was right here actually some code to draw the start line. That's just some stuff that you do while you program. You don't necessarily think of the right place to put your code right at the first round, so you put some code in a place where it doesn't belong, and eventually it turns into a function or into a subroutine. So that's a start level subroutine that we call at the start of every level. So this is right before the main game loop. You can see that here. So that's why we call that function for the first time. Nothing much changes here. As a little aside, I did look again at this weightframe loop. It's an ingenious thing. It's very simple, but I'm not going to go into it further. But has the reason why it's important is the moment that it's called. It's called at the start of the game loop, and that's when we wait for the raster beam to be right at the bottom, and that's when we do our stuff. Right. It is important. If you leave it out, it doesn't work as smoothly. This is especially important when you do full screen scrolling, and you have to do the work when the raster beam isn't drawing the screen. But anyway, we're still not using a single interrupt in this game, right? No raster interrupts, no nothing. So it's all just simple jumping through the code and doing so. So you don't need a single interrupt to do the thing that we've done so far. Enough with the babbling. We're gonna go look at letting the items dissolve. The game flow controller is, of course, a function that is called in every game loop at least once. So here's what we do. We go past all the items, right? So we load. We set X to 0. We go through the table of active items. If in a certain position there is an item none item, that means we can go to the next item, which means increase X. Check that we're not at the max item count yet. If we're not, then we go back to item loop. So if we find an item, we increase its item time. So this table only contains items when they are created. So excuse me. So when an enemy is killed, an item is dropped, and that's put in this table. So item active has an item in it. We use the other table, and in the same position for that item, we put an item. We increase its item time. So we're going to assume at this moment that the item times are all the same, or they are all 0. For this function, it doesn't really matter. We can make one item disappear quicker than the other. It increases the item time. When it's not 0, then we go to the next item. So imagine that we made the item time for an item like 255. Then that would dissolve almost immediately, because on the next tick, we'd increase that item time, it would become 0, and then we remove the item. So we can sort of play with the amount of time that an item lives. And, you know, you have to sort of figure it out, what's logical, and how long can we, you know, basically we have 255 frames to play with. If that is too short, we're going to have to think of something else. But this is, right, the single byte is enough to do it now. How do we remove an item? Simply, we put the item none code in the item active table. We have to prepare our registers for the next function, because we also have to remove the image from the screen, which means copying back out of the backup buffer what was there before we put the item there, right? So we have to, that's what remove item image. But we don't have to think about that. We just have to know that our X was probably our item number. That has to go to the accumulator, and then the accumulator item number has to go to Y as well, and that's when we can call the function. So that's how that works. I'm not going to look at remove item image again, because we've done that. Nothing has changed there. Now let's go look at the start level function, because that's the next thing down. See, there's our start level. Every function is started with a zone with the same name. This zone means that the assembler can treat the labels here as local, so that I can use clear item loop in a different zone as well, but it'll treat it as local. So that if I didn't do that, I would have to include the function name in every label to make sure it's unique, because they're all global labels, but they're not now, so that's good. So what do we do? It's nothing new, of course. We disable all the sprites. We start the level by disabling all of the sprites, right? Then we get the text display. We display the we set the text display here. We display the text, and we display the level number. This is where we display the full shells. We start each level with 2 full shells. Otherwise, it wouldn't be fair. We'd start the level with no shells. So we do that. You've seen that the image is already there, right? So all we have to do is set the color to full, right? We set a number of things to 0, number of enemies alive, level done, delay. That's, you know, when we're done with the level, we don't jump to the next level straight away. But at the start of the level, that thing is set to 0. The player sprite position X extend, you know, do we move beyond the 255 boundary, yes or no? Not at the start. And player standstill. So we just initialize some level variables, and this is where we say, okay, the player has 2 shells, and he can have 2 shells maximum. If we call this at the start of every level, that means that regardless of how many bullets you picked up in the previous levels, you're always going to start with 2. So I'm sure that at some point we're going to change this, because it wouldn't be fair if we did all that trouble, you know, went to all that trouble to collect all those shells, and then in the next level you lose them all again. So, but this is like a per level thing. We reset all the items, and we're done. So most of the stuff here isn't new, but this is important. The shell colors. All we have to do if the player picks up shells, we only have to draw some extra characters, and then keep track of where we, you know, what color we give them, because basically all we do here is change the screen color. Okay, so we've done that. The next thing that we want to do, as I scroll down here, oh right, Right. Now we're going to look at the player control function. I have to look. It's line 600. Boop. There we go. Here we go. This is player control, right? Again, this is one of those functions that's called inside the directly from the game loop. This is all the same. Nothing's changed. We're seeing to detect whether we pick up an item, we go past all the items that are active and check if their positions match that of the player, right? So after we've done that, we either pick up the item or not. Doesn't matter. Here, when the last item is reached, this is where we start checking if the player's moved. Now, how do we do that? There isn't any data that tells us whether the player's moved. We don't keep track of his coordinates. Of course, we know where he is, but we don't know where he was. So, we choose a very direct method, and this is what I like in Georg's thinking. It's never overcomplicated. It's very straight to the point, and I have the tendency to overthink these things, and he just comes up with one of the first solutions, I suppose, that he thinks of, and say, okay, this is going to work, and just don't think about it any longer. Just think about how to get it to work. So what do we do? You can tell also that he does this at speed because this should be a constant, of course, and he didn't bother to add in the constant. He just added the register that tell the first four the four least significant bits of this register are joystick input, and I think joystick 2, I believe. Yeah, joystick 2. Because DCO1 is joystick 1. And that's why it's turned around. That's why most of the games want you to put the joystick in port 2, because DC00 is port 2 and DC01 is port 1. Yada yada. What is good to remember is that those bits are high if there's no input, and they're pulled low when there's input. So what you do here, and I wanted to demonstrate that if I pull up the calculator, I've put in 1F here. So you load the value of the register, and then you AND it with 1F. Well, 1F in hex is binary this. So you can see that these bits are all high. And these are all low. If you AND a value, AND says that both of the values need to be high. So if you provide zeros in that location, you're going to force those. The result of the AND is always going to be 0. You know that because you put zeros there, and an AND is never going to produce anything else but a 0. So you get the value of whatever was here before. And I've just said that if the player doesn't do anything, if he doesn't press fire, it doesn't go up, left, right, center, whatever, then these are all going to be high. So you compare it to 1F, and if it's not equal to 1F, then the player's moved. So I'm going to shove that out of the way. So that's how you do that. So you just read the joystick. And if anything happened, then the player moved, and you can't. Oh, hold on. Right. Sorry, I had to look over to my right. If the players move, then we're not gonna reload. So what happens? We also don't reload while the player is in recoil. So right after he's shot, there is a space wherein the player cannot shoot, and in that time we also don't reload, because that recoil time also has its own animation. So we stay away from that. So simply say, if the player's shot pause value is anything other than 0, then we just say, oh, player moved. so we can't reload. So if those conditions aren't met, then we can increase the player standstill time. We load it, we compare it to 40, so we wait 40 cycles of the game loop. If it's not equal, then we can just handle fire. We're not going to reload. Handle fire is below. If it is equal, if it is 40, then we've stood still for enough time. We set the player standstill time to 1 because we've stood still long enough. Next, we have to see if we're already fully loaded. You know, if we load the number of player shells that we have, we compare it to what the maximum number of shells are. If they're the same, then we can go handle fire. You know, we can just do the rest. If it's not, then we increase the actual player shells. Remember, we're standing still. We've stood still long enough. We're not in the short pause. Now is the time to start increasing the number of shells that we have. We have to display that, so we load Y with the number of player shells that we have. That is going to give us the position of the bullet that we have to give the full color. So colors 2 and color 7 for the top and the bottom are going to give us the full shell color. So that's what we do here. With every shell that we increase, we give it a new color, and that's what you see happening. So that's it. You know, we increase the number of shells, like the data says. Okay, we have one more, and then we paint the color, and then we're done. You know, we do the rest of the program. If the player's moved, then we set the player standstill time to 0. Now, I didn't really look at why there is a difference between 1 and 0. I think no, player standstill time. We don't check that anywhere in here, so I'm not really sure. Player standstill time goes to 0. We have to reset that because when we detect a player move, then we have to set the player standstill time back to 0. So every time we start moving with before this 40 frames gone, we have to set the thing to 0 again. So that's what happens. Then what we haven't done yet is the animation. So animation that happens at the end. We're still in the same routine. That's the player falling, and the player control function is by far the most complicated and the longest one. Right? This is here we check the joystick again. We already did that. The code that I want to look at is not left pressed, not right pressed. Here we go. Here we go. The animation. We know that after 4 T frames, we start reloading. So we have to figure out somewhere in that time that we have to do the animation, right? So here we go. We load the player standstill time, whatever it is at that moment. We check that if it's 0, then the player moving, then the player's moving. Then we don't have to do the animation. If we compare it to 10 and the result is minus, that means that we've not yet done 10 frames. Then not reloading means we're not doing the animation. If we're over 30 frames, we're not reloading either. So somewhere between, see what we're doing here? We're doing a check whether player standstill time is greater than 10 and smaller than 30. So we have like a a frame, a time frame in which we can do the animation. Which means that, it's not smart to do like an exact check, like if it's 20, because the chances are that you don't reach this code exactly when the player standstill is 20. So we do a range check. Between those values, we do a player the animation. So what we do, we load the number of shells. We compare it to the max. Oh, if we already have the maximum number of shells and we're not going to do the animation at all, just as we did that before, we don't get any actual, so that we don't get an animation without the reload or a reload without the animation. So those have to match. If you are reloading, then we take the sprite player reload sprite shape, and then we have to calculate which sprite shape exactly we need. That's based off the direction, right? So we could be either standing right or left, and right is the first one here. We add sprite direction, 1 or 0, and then we add the sprite pointer base, and that gives us the actual number of the sprite shape that we need. And then we're done. So that's just one shape. If we're not reloading, we get just a player stand R. So there's a reload R and a player stand R. It's two different shapes, and that's what gives the animation. Now we could never do this if we didn't have a proper base. Now there's still a couple of things that we have to do, because we have to have an effect. If we pick up an item, I'm scrolling down here. If we pick up an item, something has to happen. So there's a function, pick item. We load the item active table. It actually has the item types in it, right, in each position. So if it's an item bullet, then we do the effect bullet. If it's item health, we do the effect health. So what is the effect bullet? We load the number of shells that the player can have. We compare it to 5. That's obviously... see that? Remove item. Oh, okay. Okay, so if we have 5 bullets already and we pick it up, the effect is that the item is removed and we don't get any extra. So the max number of player shells max is 5. Okay. Then we get the maximum number of shells that we can have, and we start adding them. See, character 224, we write that in screen character memory, so we write that on the screen. Remember that we don't write this to the backup memory, but we don't have to because we don't place any items at this portion of the screen. So we don't need to put this in the backup because it's never used, okay? So we put the top bit in and the bottom bit, and we give it a color, but we give it color 6, right? When we pick up an item, we pick up an extra bullet space, but it's empty. We don't have it yet. And then we increase that. We increase player shells max. We increase that number. And remove. Oh, of course, we have to remove the item. Increase the player shells max, of course. So we load the number that it was. Yeah, so I think we have to assume that X points us to the next position now. Right? There's a number and there's a position. So obviously player shells max starts off with 0. Because if we pick it up, and max points us immediately to the next position. See that? Okay, so this is something that you have to figure out. I would say, okay, maybe we have to increase X, but apparently it's already pointing to the next empty position on the screen, and that has to do with where we start drawing, of course. 23, 24 plus 19. Yeah, that is probably it. This allows us to set the offset that from the start of where the bullets are drawn, right? So basically, we just draw the empty bullets on the screen. That's it. So we when we pick up the item, that's what we do, and the data is handled in the other in the other functions. Health effect, of course. We load the number of player lives. You compare it to 99. If it's already 99, then we're not gonna get. So we can get 99 lives. Okay. We increase player lives. Of course, we have to display the lives number, so we do that there, and then the item can be removed, and that is it. There's a couple of things. I think that something was debugged that I'm not gonna show. It's not interesting. Well, it may be interesting. You know, I don't want to keep anything from you. Right here, the X register is stored in parameter 3 at the start of the function, and at the end of the function, the X register is restored. So apparently, this function, and you can see it right here, this function was using X. So you can, and that is one. See, the documentation here says Y is item index. That means input. All right, this function, this subroutine expects Y to be the item index when you call it. But what it doesn't say is that during running this function, it mangles X and Y. So we have to restore that. And it apparently didn't do that because this was added and this was added, but nothing else. So it's just a restoration of the X register. Apparently something was going wrong, and he figured out that was the cause. Now, what happens when you fire a shot? Of course, is another moment that the shells come into play. We fire the shot. We decrease the number of shells that we have. We load it. Color 6, that's the blue one. We have to color that shell blue. LDA and Y points to the number of shells, right? We have to work that out. And the rest is all. That's the rest is all the same. So basically, we just paint them off the screen and decrease the number, and that's it. Now, there was one more, a couple of more changes. Right. When we spawn an item. Oh, okay. This is interesting. Spawn an item at 12:28. Spawn an item. So when we shoot an enemy, an item is spawned, and we set the item time. We set the item time of a spawned item to 0. So, and then it's increased. So every item is left there for the longest possible amount of time that one byte can hold. So that's what we needed to do. And so you can never assume that a variable is initialized automatically. You have to take control of that. You have to know. You can't guess. 23:27. Okay, we have to call the new start level function. So that's not so weird. When we build a screen, there's a start level function that we call. But that makes sense, doesn't it? And then we've had them. And then we've seen all the changes. So, interesting, this one. Also a little bit complex, but we've been going for about 40 minutes now. A little bit complex, but still, you know, when you look at it, when it comes down, you have to think in game terms. You know, what do we add bullets, remove bullets? It's all game thinking. It's not really, I mean, the fact that it's assembly is almost unimportant now. So, this was step number 20. We're at 20%, and I can keep saying that because there's 100 steps. But we're making good progress. And please join me for the next one, which will hopefully be next Friday. And otherwise, I will see you in another video, maybe. So thanks for watching, guys, and I'll see you next time. Bye-bye.